This is the 2024 Deferred Paper 1. It's a long question on calculus and it's question 9. So in the question we are given two functions fx and g of x, and they're defined clearly here for us. We're also given the functions on a graph, so it shows fx, the first function here, and the second function gx over here. Now also we're asked in part A to find out where g cuts the x-axis. Now, as we know, the x-axis is wherever the y value is 0. So what we have to do is we have to verify that x equals 1.5 fits. So you put in 1.5 for x basically in the function g, and you find out that the y value indeed is 0. So that proves that it cuts the x-axis at that point where x is 1.5. So now we know that that point there is 1.50, where it cuts the x-axis. So keep that in mind for later in the question, that the point B is 1.50. Okay, on to the next part. So some keywords here that we should always recognize in an exam question: the word calculus obviously, and the word maximum. Now a maximum means something very specific in maths. In these questions it means dy dx is 0, equals 0. So you take your function and you rewrite it slightly to make it easier to work with. I recommend this. Just take that 4 under the line over here. It's minus 1/4. It's easier to write it that way. And then we go and differentiate. So f dash of x then, a number in front in differentiation always stays the same. It's not touched, it doesn't affect things. You just worry about the x cubed, so the 3 comes on in front, 3x squared. X squared goes to 2x. And because it's a max, we put it equal to 0. And this is the part that students forget the most often, I find, in exams. So watch out there. When it's a maximum, you get to, there's two parts to that. You differentiate and put equal to 0. Okay, now you have that equal to 0. What do you do next? So what the proper procedure here, we don't divide across by x because x could be 0. What we do, or cancel x, which means the same thing effectively. What we do here is we see that x is in both terms, so we take out the x outside the bracket. And what's left in the bracket is here, minus 3/4 x plus 2. Now we've got something multiplied by something equals 0. X by something is 0. Which means one of the somethings is 0. Either x is 0 or the thing in the bracket is 0. And so just to remind you, when two numbers multiplied together give you 0, that means one of the numbers has to be 0 at least, if you think about it. That's all we're saying there. So x equals 0. The only trouble now is which is which. When I say dy dx is 0 for the max, the other thing is that also works for the min, a minimum point. So which a local max and a local min. So which is it in this case? So what we have to do is we can use the graph to see which one it is. And if you go back, you clearly see that at 0 there's a min. If you take the fx function, that's the minimum point there. So we know that there's a min at x equals 0. You might think that's obvious, that the smallest value of x is the minimum, but be careful here, it's the y value that determines the max or min. The y value is the height, or where the y value can be, but the higher y value is always the max. Okay, anyway, so we know that's the min, which means the max, the one we're looking for, is this one over here. And we solve this one here, we get the x to one side, and we find out that x is 8/3. Now again, watch the details in the question. It's the local maximum point. That word point is a trigger word as well, because it means there's an x value and a y value required. Every point has an x value and a y value. So little words like that really matter. So come down here, we have the x value, sub it back into the function to get the y value. And now you have your point. When you do that, you get on the calculator 8/3, 64/27 is the local max. Part C. Use calculus to find the x-coordinate of the steepest part of the graph. Now again, if we go back to the graph for a sec, the graph is here. Where is the steepest part? If you're going up this graph like a slide, where's the steepest part? From common sense even. It's hard to know, I suppose, until we work it out, maybe up around here someplace. We'll see anyway. The maths that's going on here is as follows. The steepest part is English, but convert that to maths language. Steepest means the maximum slope. Think when something is steep, it's got a slope. And the steeper it is, the higher the slope. So we're looking for the max slope. That's the first thing. Now, we do have maths language to describe that. I mean, slope is m. So, and we do have language for max as well. As we just saw, max means differentiate and put equal to naught. So you take your slope, m, you differentiate it, and put equal to naught. However, don't forget the slope itself is dy dx. That's the very meaning of dy dx. It's slope of a tangent. So the slope itself is dy dx. So you're really getting the dy dx of the dy dx, which is basically d2y dx squared. So that's an awful lot packed into that one word there. That's a very loaded word, steepest. All of this here is packed into it. And so we now know that we're actually looking, it's hard to believe from the way the question is stated, but what he's really asking, if you wanted to be more succinct, the examiner would have just said get d2y dx squared. But obviously he's trying to understand if you know the connection. Okay, so once we know what we're looking for, it should be easy enough to get d2y dx squared. That means you start off with your dy dx, and you get your dy dx again, basically, of this. So I mean, maybe we should call that d2y dx squared. It doesn't matter, it's over here anyway. So if you differentiate this again, well, that comes on in front, it stays as it is. That becomes 2x. 2x goes to 2. And again, because it's max, equal to 0. Very important. In exams, I find from correcting students, again, when they're getting the max, they often get the dy dx, but they keep forgetting for some reason to put in equal to 0 to get the full marks there. Okay, so solve for this, bring this across the x, and you have x equals 4 over 3. So that's the steepest part of the slope, where x is 4 over 3. If we go back for a sec, we weren't asked this, but it's no harm to look. Where is x equal to 4 over 3, which is 1.3 roughly, which is around there someplace. So he's telling us that the steepest part of the graph is around there. Okay, on to the next part. Use integration to work out the area of the image. So the area in here, in this logo, we want to get this area. Now, we should know that integration, when you integrate a function, you're basically getting the area between that function and the x-axis. That's by definition, when you integrate any function, you're getting the area between that function and the x-axis. So for example, if I integrate this function here, I get the area between that and the x-axis down here. So I get all this area in here. And if I have limits on it, I can go between 0 and 2. So that reduces it to between here and here as well. So that's how you get area. Now, so that's the area, that's fx. I can also get the area under the function gx, between gx and the x-axis, by integrating the gx function. And that gives me that little piece in here. But I want what's in between. So it should be obvious now, if I could integrate fx, which is anything under this, and integrate gx, which is anything under this, and subtract to get what's in the middle, what's in between. That's the answer. Watch your limits though. The limits for the first function are if you integrate from 0 to 2 to get everything under this function here. And in the second one, it's everything from 1.5 to 2, from there to there, to get all this area, which we have to subtract to get the remaining piece in here. So that's what's going on. It's just two integrations and you subtract. So we'll show our functions here. So integral of the first function, integral of the second function. And we're going to subtract the two areas. So that's the big one minus the small one to get the area in between. That's why there's a minus. Now, integrate properly here. Just be careful again. You might need to take an extra step. Take the minus a quarter outside again. It's easier, and then just worry about the x cubed. If you integrate that, it's just increase the power, divide by the new power. That's the rule for powers and integration. And the x squared goes to x cubed over 3. Hold on to your limits with a straight line, 2 and 0. Minus. Same here. Put the minus 6 in front. X cubed over 3. Put the 25 in front. X squared over 2. Minus 24x. I mean, think about it. If you had 24x and differentiated, you get 24. So the reverse integration. If you integrate 24, you get 24x. Hang on to your limits with a straight line, 2 and 1.5. And now it's just calculator work really. You put in the top limit, it's always top minus bottom, so put in the 2 for x there and there, here they are, minus, put in the 0 for x, so that's just 0 in both cases. The same over here, it's always top limit minus bottom limit, so put in the 2 for x everywhere, x has become 2 in all those there, and put in the 1.5 for x, and subtract your answers, top minus bottom always. And work all that out in the calculator and you get 5 over 8. And for the first one you get, 5 over 3. Subtract your two areas and you get 25 over 24. And that's the area of the logo that we're looking for. That's basically it. Now the last part of the question, it's a long question, so there's a good few parts here. Part E, a very common type of question. You've got a cone, and so this word cone is a trigger word. Whenever you see that in a question in section B, usually in paper 1, a cone or a cylinder, any of those words, you look up the table straight away and you get a formula, which I did down here. So for the cone, the formula is volume is a third pi r squared h. So that's your trigger word. Okay, what's next? We're told in this particular cone there is something special. Because we're told its height h is the same as its diameter. Again, what's that in maths language? That's English. What's it in maths language? Well, if your height is the same as your diameter, height is twice the radius, basically. H is 2r is an equation we can now use. And we put that in down here. H is 2r. And you work it out. The 2 goes over here and you get r cubed. And that's exactly what we were asked to prove. So that's the first part done right there. Now, always be alert as well for connections between parts of questions. That's the way the examiner works. So we're probably going to use this now in the next part. So I've been nearly writing it down straight away down here, in case I forget it later. Okay, so now we'll go through part 2. The volume. Again, I'd be converting English to maths. Volume is V of a cone. So we've got that already, the cone down here, volume. It's increasing at a rate of 0.5. Now this again is loaded language. It's you know, it triggers us to a rate of change is always a differentiate. So basically we're differentiating volume. It's the rate of change of volume basically. So we know now that's dv dt equals 0.5. So I'd write it again in maths language to make things clear for myself. Even if you didn't know that anyway, you get it from the units. Centimeters cubed per second is volume over time, V over T. So we have this, we're given this in the question. Now what do we want? Find the rate at which the radius of the cone, okay? So rate and radius. So that's another trigger term. It's radius, so it's dr dt this time. No, this time we don't have the answer. So I'll actually explicitly put a question mark to say, I know clearly what I'm looking for here. This is to clarify for myself and the examiner, listen, I know what I'm looking for at least. I'm looking for dr dt basically. I have dv dt, but I want dr dt. It's increasing when the radius is 4, so that's clearly r equals 4. Okay, so how do we tie all this together? Well, we're looking for dr dt. And I write it like this. I write my dr up here and I can write my dt under here. It's still dr dt when you read it like that. But I'm going to put in a chain, kind of a dv in both places to chain them together. So that's dr dv now, that's dv dt. But overall they cancel, it's still dr dt. So why did I do this? This is called the chain rule, by the way, from differentiation. They're chained together by the v. I introduced the v because I know I have a v up here to do some work for me. And that can help me to get from, I'm trying to get from A to B. I'm given this in the question, I want this. So I'm trying to get from A to B, but there's an intermediate step with V that can get me there basically. So I work with my V up here, I have V equals this. I can now differentiate V, dV dr. And a number in front just stays the same, 2 over 3 pi just stays the same. That 3 comes on in front, it's r squared. And tidy up, the 3's cancel, you get 2 pi r squared. So that's dv dr. But if you look over here, I want dr dv. Well, if that's dv dr, dr dv is the same thing upside down. I mean, that's over 1 really. So 1 over that is dv dr. And if I have dv dr, I can just put it, or dr dv, I can put it right in here to my formula. And dv dt we were given at the very start. We were given this, so we have that too. So now we can get what we want, dr dv, dr dt. We can just tidy up. By the way, leave pi in the answer. Don't put pi in the calculator. It says it there. So put the rest in the calculator and you get 1 over 64 pi centimeters per second. So that's the rate at which the radius of the cone of melted wax is increasing. It's increasing at a rate of 1 over 64 pi centimeters every second. And that's the end of the question. Question 9.